Today we're in 9.2, simplifying square roots. The other day we learned, square roots, radicals, basically all those basic definitions. But one of the most important concepts that you need to understand for today's lesson is the concept of a perfect square. And a perfect square is the product of two numbers that were multiplied by themselves. Like 2 times 2. What's 2 times 2? 4. So 4 is a perfect squared because a number can be multiplied by itself to equal that number. All right, so what's another perfect square? 14. 9, 16, 25, 36, 49, 64, 81. Basically, you can tier it up by just going, okay, well, 4 times 4 is 16, 5 times 5 is 25, and then you just go up. 6, 7, 8, 9, 10. And whatever the product is, that number is a perfect square. When you are simplifying square roots, you're essentially pulling out from underneath the radical numbers that are perfect squares or variables that are perfect squares. So that's what this first slide is showing us. It's showing us how the square root of 4 is 2, and the square root of 16 is 4, so 2 times 4 is 8. So underneath the radical, well, they kind of did this backwards, but the square root of 64, okay, that's kind of confusing. But basically, I think it's just basically talking about the product property of square roots, but basically, what I want you to understand from leading into examples 1 and 2 is that I can break down a number like 64, even though 64 is a perfect square, or a number like, let's say, let me just make up one so I can get my point across. The square root of 32. Is it a perfect square?
No.
No, it's not. But it has factors that are perfect squares. The largest of them is 16. So I could say that the square root of 32 is the same thing as the square root of 16 times 2, right? 16 times 2 is 32. And out of those two numbers, is one of them a perfect square? Yeah. So I can pull out that number, take the square root, and I leave underneath my radical anything that is not a perfect square. Okay? And that is essentially how I simplify a square root. I pull out the factors that are perfect squares and I leave everything else under the radical. That's my product property of square roots. Okay? You don't necessarily have to have that part written down because I'm going to give you another example where you will write it down. All right? So, let's skip that because we already talked about that. All right, this is an important slide. You can know that a radical expression is in simplest form when no factor under the radical sign has any other perfect square factor. So that means what you leave under the radical cannot be broken down into a perfect square factor, and you can't take the square root evenly. All right? And then there's no fractions, no radical sign in the denominator of any fraction. All right, so lots of words. Let's see how it plays out now in the examples. Okay? All right, so let's look at example 1. Okay? In example 1, it wants us to simplify the radical expression, the square root of 180. Well, the square root of 180, although it's not a perfect square, it has factors that are perfect squares. So I can pull out part of this number, but first I have to figure out what is the largest perfect square that goes into that number. And that's where my calculator can come in handy. And what I'm going to say now, all right, I'm not 100% on what your Algebra 1 teacher will require you to do, but I am not going to require you to show a lot of work on these. Okay, your homework assignment tonight, it encourages you to use your calculator, so I will allow it too. But here's what I want you to understand, basically how we're getting to our answer. I can break down the square root of 180 to the square root of 36 times 5. 36 times 5 is 180. But I now have broken it down into two factors, and one of which I can take the square root of. Which one? Which factor can I take the square root of? 36. And the square root of 36 is what? It's 6. So 6 times the square root of 5 is my final answer. How do I know it's my final answer? Because I can't evenly take the square root of 5, can I? And there's no factor of 5 that's a perfect square either that I could break it down into. So that's how I know that it's in simplest form. Now if you get out your calculators and take the square root of 180, especially if you have a Casio, the Casio actually gives you the simplified answer. So essentially, you do not have to show this step if your calculator can perform that function. Okay? Now, if you have some just basic calculator that doesn't give you the simplified answer, then you will have to figure out what is the perfect square that is a factor of this number, and you'll have to do it manually by hand. All right? So this is definitely a lesson that it's going to benefit you to have the correct calculator. All right, so the square root of 300 now, I could break down to, and again, you don't have to show this step on your homework, but I want you to see. Can anybody think of a large perfect square that is a factor of 300?
20.
Not 150. It's got to be a perfect square.
20. Wait, no.
You said it earlier. I heard someone say it. 100.
100.
Is 100 a perfect square? Yeah. And 100 times 3 gives me 300. Again, you don't have to show this step if you have the Casio, but I want you to understand the reasoning behind it. Now, the square root of 100 is what? 10. So we pull it out from underneath the radical. 10 times the square root of 3. If you put the square root of 300 in your Casio, it gives you 10 times the square root of 3. But that just kind of gives you a little bit of the why behind it. I want you to go ahead and solve the last one. All right, and what did you get for your answer?
21 times the square root of 2.
21 times the square root of 2. Okay, and that's your simplified answer. Not a whole lot of work to show in your homework tonight, but are you guys kind of catching on to some of these common themes? You only pull out of the radical what you can take an even square root of. Okay, so that's why perfect squares are important to this lesson. All right, example 2. Now we're going to simplify a variable expression. So now we have variables involved as well. Okay? So we need to pull out what we can out of the radical. All right, and I just need to go ahead and mention that these are errors. You're not going to see anything above an exponent of 2 on your homework quiz or test. That's a little bit more advanced than pre-algebra. But you will start taking the square root of exponents that are greater than 2, but just not in today's lesson. All right, so now for the numeric part of the simplifying, the square root of 24, you can do that in your calculator. Okay, so go ahead and take the square root of 4 in your calculator. And what do you get?
4 or 24?
24, sorry. You get 2 times the square root of 6. But now you still have this s squared. Well, if a variable is squared and I take the square root, we did this in the last lesson when we were solving equations. If I take the square root of s squared, what do I get? Just s. Isn't that what we did when we solved equations? We took the square root of both sides. Okay, so I just have s. So I can pull out the square root of s squared also. All right, and I would just have 2s times the square root of 6. Okay. All right, so on the next one, again, you can use your calculator to do the numeric part of this. What is the square root of 32? What's the square root of 32, guys? 4 times the square root of 2. Now, what's the square root of x squared? X squared. It's just x. So my answer is going to be 4x times the square root of 2. Okay, I pull out the square root of x squared, which is x, and then I break down the square root of 32 is the 4 times the square root of 2, so that's how I came up with my answer. I want you to try the third one on your own. All right, Colin, what's your answer?
2r times the square root of 6.
Very good. 2r times the square root of 6. Who got that right? You got it right. Very good. All right, example 3 involves quotients or division. Okay, so this is what it's going to look like. Now, if I'm taking the square root of a fraction, I am essentially taking the square root of my numerator and the square root of my denominator. It's important that you recognize that they are separate, okay? They are not together. So, can I take the square root of either my numerator or my denominator evenly?
No.
Which one? 36. What's the square root of 36? 6. Now, 13 is not a perfect square, obviously. Are there any factors of 13 that are a perfect square? No. If you're not sure, you put it in your calculator. What is the square root of 13? What does it give you? The square root of 13. There's no perfect square that can come out of it. So my final answer, my simplified answer, is square root of 13 over 6. You take the square root of whatever you can evenly. You leave everything else under the radical. All right, so that's like saying square root of 50 over the square root of 81. All right, well, I know the square root of 81 is 9. Okay, and what's the square root of 50?
5 times the square root of 2.
So 5 times the square root of 2 over 9. And that's my answer. All right, go ahead and do the third one. All right, so what'd you get for the third one? You got 3 times the square root of 2 over 5. Okay, who got it right? Awesome, good job. All right, moving on to example 4. All right, in example 4, I personally just feel like your book made it a lot more complicated than it needed to be. So I'm going to give you my version of it, and we're just going to go from there. Now, the word problem gives me the radical expression. This is like a radical expression that you've been using, except now I'm going to substitute a value for the variable. Okay, so I'm going to use the 27L. Let me see. Sorry. I'm going to use 27L. Let me just go over here to my paper. The square root of 27L. And the problem tells me that it says basically after a car accident, the police officer is trying to measure the length of the car's skid marks. So he uses this expression, the square root of 27L. And then they later tell us that the skid marks are 125 feet long. So what we do is we substitute 125 for L. Okay? And 27 times 125 gives us 3,375. Okay? The square root of 3,375. And when we simplify that, what do we get?
15 times the square root of 15.
15 times the square root of 15. Now, the only way that I can know if this is simplified is by asking myself, is 15 a perfect square?
Yeah.
No. And are there any factors of 15 that are perfect squares? No. Okay, so that is going to be my answer. Now, your book takes it a step further, and they actually simplify this into the decimal form. If you press your S to D button, it will tell you, because is this really a mile per hour answer? Okay, if this police officer sergeant came up to him and he said, all right, Joe, you were supposed to figure out, how fast this car was going. And Joe says, oh, the car was going 15 times the square root of 15 miles per hour. What do you think the sergeant's going to say to him?
You're fired.
Yeah, he's going to be like, dude, that's the worst answer ever. I just need the answer in miles per hour. So that's why your book goes ahead and converts the answer into decimal form. And what is your answer in decimal form?
58.1
Yeah, it's going to be about 58 miles per hour. Now, I will tell you this. This answer right here, that's the right answer, okay? And that's the answer that we've done in all three of our other examples. The only reason that this is our answer here is because 15 times the square root of 15 is not a practical answer. Does that make sense? Okay, so be careful with the word problems. You may need to convert it to its decimal form, if that makes sense. Okay? On a quiz or a test, this is probably your safe bet answer. But again, sometimes it's not the most practical. All right, if you understand that, that's everything you need to know for 9.2.